1. Elemental characteristics. Cerium, CEE, is the chemical element with atomic number 58 in the periodic table. It is a silvery white, soft, ductile, and malleable metal that tarnishes when exposed to air. Cerium is the most abundant of the rare earth elements and is found in various minerals, including monazite and bastnasite, which are primary sources of rare earth metals. 2. Discovery. Cerium was discovered in 1803 by Jöns Jakob Berzelius and Wilhelm Hisinger in Sweden, and independently by Martin Heinrich Klaproth in Germany. The element was named after the dwarf planet Ceres, which had been discovered 2 years earlier. 3. Physical properties. Cerium has a melting point of 798 ddJoC, warm 468 Do F, and a boiling point of 324 ddMoC, 6195 Gro F. It has 2 allotropic forms, structural forms: A-cerium, which has a face-centered cubic crystal structure, and G-cerium with a body-centered cubic crystal structure. 4. Chemical reactivity. Cerium is a highly reactive element, especially at elevated temperatures or when finely divided. It oxidizes slowly in cold water and rapidly in hot water. Cerium can burn in air to form cerium-30 oxide. It reacts with all halogens to form cerium halides and can also react with most acids. Alloys. Cerium is used in aluminum and magnesium alloys, where it improves strength and oxidation resistance. It is also used in stainless steel as a precipitation hardening agent. Glass and ceramics. Cerium oxides are used as polishing agents for glass and are added to glass to filter out ultraviolet light. They also serve as a component in ceramic materials to enhance color and durability. Catalysts. Cerium compounds are used as catalysts in catalytic converters in automobiles to reduce emissions of toxic gases. Cerium oxide is particularly effective in converting exhaust gases from combustion engines into less harmful substances. Chemical manufacturing. Cerium iphorous sulfate is used in the oxidation of organic compounds in chemical processes, including the synthesis of pharmaceuticals. Electronics and lighting. Cerium-doped materials are used in the manufacture of fluorescent lamps and as phosphors in television screens and LED lights. Environmental applications. Cerium compounds are utilized in water treatment processes and air pollution control due to their oxidative properties. 6. Occurrence. Cerium is the most abundant of the rare earth elements, making up about 0.046% of the Earth's crust. It is extracted from rare earth mineral ores like monazite and bastnasite through complex metallurgical processes involving crushing, milling, magnetic separation, and chemical treatment. 7. Toxicity. Although cerium is not highly toxic, its compounds should be handled with care due to their potential health effects. Inhalation of cerium dust or fumes can cause lung irritation, and prolonged skin contact with cerium compounds may cause irritation. 8. Environmental impact. The mining and processing of cerium and other rare earth elements can have significant environmental impacts, including habitat destruction, water pollution, and the generation of hazardous wastes. Efforts are underway to develop more sustainable and less harmful extraction and processing techniques. 9. Isotopes. Cerium has 4 naturally occurring isotopes: cerium-136, cerium-138, cerium-140, and cerium-142. Of these, cerium-140 is the most abundant. 10. Research and development. Ongoing research into cerium and its compounds focuses on enhancing their catalytic properties, developing new materials for electronics and energy applications, and improving environmental remediation techniques.
Thank you for watching. Please subscribe for more.